For analysis of variance, we consider an example. A study was conducted to test the question as to whether cigarette smoking is associated with reduced mean serum testosterone levels in mean aged group between 35 to 45 years. The study involved the following four groups. The first group is non-smoker who had never smoked, two former smoker who had quit for at least 6 months prior to the study, light smoker, those who smoked 10 or fewer cigarettes per day. The fourth one is heavy smokers, those who smoked 30 or more cigarettes per day. Data sets is given. Here we have 40 total 40 participants and total 40 participants in each group 10. The hypothesis of this example H naught null hypothesis, there is an evidence that cigarette smoking groups are not associated with reduced mean serum testosterone levels in aged group 35 to 45 years. And the alternative hypothesis, is there an evidence that cigarette smoking groups are associated with reduced serum testosterone levels in mean age group 35 to 45 years? The mu1 is known the group 1 non-smoker, mu2 represent the former smoker, mu3 represent the light smoker, and mu4 represent the heavy smoker. First, we open our SPSS and create three variables. The first variable is serial number, the second variable is group smoking groups, and the third variables is testosterone level, and create all variables properties in variable views. Here we have a group variable, smoking groups. We first enter the values of smoking groups, one for non-smoker, two for light smoker, and three for heavy smoker, and add all groups and press the button OK. And we enter all 40 observation in data view. Go to SPSS data view and enter the serial number 1 to 40 and the smoking groups and their testosterone level. For applying the analysis of variance in SPSS option, we go to analyze descriptive statistics and explores. When open the explore window, we move our test variable independent list and the factor variable smoking groups in factor list and press the button plots window is open, and here we check the normality plots with test and press button continue, and in explore window press button OK. Here we have the output of SPSS output for analysis of variance. The first table show the case processing summary, and the second table show descriptive, and the third table show the test of normality. Descriptive statistics show the mean 95% confidence interval of 5% trim mean, median, variance, standard deviation of each group separately. And the test of normality show the all groups normality p-value and Shapiro-Wilk test statistics. Here all p-values is greater than 0.05, so we accept our null hypothesis. All groups are normally distributed, and box plots show the no outlier in each groups. SPSS steps for analysis of variance. We go to analyze, compare means, one-way ANOVA, and move dependent list, serum testosterone levels, and the smoking groups in factors, and press the option button. Option window of one-way ANOVA is open, and we check the descriptive homogeneity of variance test and mean plot, and press continuous and press OK in one-way ANOVA window. Here we have descriptive test of homogeneity of variance and ANOVA tables in output viewer. The first is test of homogeneity of ANOVA. Show the p-value 0.460, which means all groups variances are equal, and test of homogeneity of variances is assumption is fulfilled. And the ANOVA test f value is 3.798, and the p value of this test is 0.018, which means all groups means are not equal, or one pair of means is not equal. Our results and conclusion is our p value is 0.018, which is the less than 0.05 alpha. So we reject our null hypothesis. We conclude a 5% level of significance that there was an evidence that cigarette smoking is associated with the reduced mean serum testosterone level in mean aged 35 to 45 years. For post-hoc test, if our analysis of variance is not equal means, so we use post-hoc test and check the which groups or which pair of means is not equal. So we go to analyze and compare means and one-way ANOVA, and move our testosterone variable independent list and smoking status in factors, and press the button post hoc and apply the post hoc Tukey test, and press button continue in multiple post hoc comparison window, and press OK button in one-way ANOVA window. Here the hypothesis for post hoc ANOVA. The H naught show the mu1 and mu2 is equal to mu2, mu1 is equal to mu3, mu1 is equal to mu4, and mu2 is equal to mu3, mu2 is equal to mu4, and last one pair is mu3 is equal to mu4. Here multiple comparison test window show 0.03 and 0.036. 0.03 where non-smoker was heavy smoker, or 0.036 former smoker was heavy smoker. Both groups testosterone level, mean testosterone level is not equal. Okay, we conclude at 5% level of significance that there was an evidence that mean serum testosterone level significantly difference were found in non-smoker and heavy smoker group and former smoker and heavy smoker groups. Cigarette smoking groups in mean age group 35 years to 45 years. The last one is mean plots, homogeneous subset. Both groups are show the insignificant result 0.508 p-value show and 0.446, which means the group heavy smoker and light smoker and light smoker second subset light smoker, former smoker and non-smoker. Thank you so much. Please subscribe and like our channel and press bell icon for more videos.